Hey, this is Itakshi. So I built an MLET system from scratch for the Neuron 4D Sky Bounty, and I want to show you what I ended up with and the journey of getting here because it was not straightforward. So when I first connected to the Neuron SDK, all I got was this raw byte stream, a length prefix, and then packed binary with sensor IDs, timestamps, and raw mode as bytes. No documentation on the packet format. I had to figure out by staring at hex terms. Then I realized some sellers were reporting wrong GPS positions for themselves. So I had to build a location override system that maps each sensor's public key to corrected coordinates that alone took a minute. Now, for decoding, I started with just DF17 ADSB because that's the obvious one. But then I realized TF11 all call is way more common and it carries no position at all. That's why MLAT workload. So I went back and implemented downlink format 0 through 21, CRC recovery, Gilham altitude, CPR positions, decoding with NL zone checks, call sign extraction, all four velocity subtypes from TC19. I am catching call signs and velocity per ICAO and attaching them to every MLAT results so the dashboard shows ATSB quality metadata on aircraft that never broadcast their position. Now here is where I got stuck actually. Clock sync. My first solver attempts were giving me wrong positions scattered all over the place. I measured -22 to +13 nanosecond across the network. Sounds tiny, but 1 nanosecond is zero point 0.3 meters of range errors and it's systematic. It doesn't cancel out. So I built a Kalman filter that uses ADSB aircraft as calibration beacons. Plain set nodes, GPS positions tell me what the TTOA should be. I compare against what I measured and the filter converges on each sensor's bias. I am running my own CPR decoder inside the calibrator for that. The moment I turned this on, my solution snapped into place. This was single biggest breakthrough in the whole project. For the actual solver, I tried a bunch of approaches. Started with basic TTOA, least squares. It was terrible. Literally, it was terrible. Then I implemented Canho closed form, which gave me a decent initialization. Okay, and I feed that into Levenberg Mark II for refinement. I use TOA instead of TTOA for LM because differencing against the referencing sensors was adding correlated noise. I also added IRLS with Uber loss as a fourth solver path for when a sensor is being noisy. All four complete lowest residual wins. Ghost solution just lowers the competition. I don't have to detect them explicitly. And the last thing that's really moved the numbers, I added a match 2.5 speed check in the tracker. If two consecutive fixes imply faster than physically possible movement, throw it out. Just throw it out. That's one line dropped my median innovation from 20 to 87 meters to 72. Way better than any solver tweak I tried. Results are on the bottom: 135-meter median residual, 72-meter innovation, best aircraft at 34 meters. Let me show you it's running. So this is tw1nkl3.rest, my dashboard. I built this with maplibra and deck.gl. It's all embedded in the Go binary. These are real aircraft over Cornwall right now. The arrows rotate with heading. Those took me a few tries to get right. I was drawing them on a canvas and converting to data URL for the icon atlas. The rings with crosshairs are at the 9 sensors. Let me click on this aircraft here. You can see the arc lines from each sensors, the detail card with the altitude, speed, word rate, fixed count. Up here in the HUD, fixed rate, track count, and this is the HBI balance. When that drops below 5, the whole dashboard throws up a refuel overlay with the account number. Okay, so and this HCS link, if I click it, it takes you straight to hat scan. These are the actual attestation messages on the Hedera. Every fixed ICAO position, residual method, on chain, and verifiable. So, yeah, that's the full journey. Started with a raw byte stream and no documentation, ended up with a complete pipeline doing real time multilateration with Kalman clock calibration, multi start solving, physics based tracking, and on chain attestation. One go binary, no NPM, no build steps, ships the entire dashboard embedded. It's been running 24/7 at tw1nkl3.rest. Code is on GitHub. Thanks for watching. I'm Hitakshi.